Hello everyone. So in this video we are going to discuss about the difference between the jitter or latency or throughput. Okay, so this is the common terms we were hearing while a lot of discussion. We were just hearing these things, right? Jitter or latency is throughput. So these three have its own definitions. Yeah, we'll just discuss about this. Okay, first we'll talk about the throughput. Okay, so consider if you have a system, okay, one system, any system we have to just you have a system, so that system it's like you will be having a lot of combinational as well as sequential logic inside it. So the throughput of the system will be defined as like you will be getting the input here and you will be getting the output here, right? So in which rate, okay, in which rate your output is you are getting, like number of bits per second, right? So if your output is coming out in a speed of consider 33 megabits per second, so megabits per second, so per second how many bits it's sending out to the output, so that is we are calling it output. Okay, so in which rate we are giving the input and which rate we are getting the output, so that throughput is something like it's with respect to the speed we are telling. So per second how many number of bits getting transferred, so that is what we are telling as throughput. Okay, so this is what about the throughput. This is this is we are calling this as a throughput. Okay, throughput is this is only, so only with respect to the output we are telling. And okay, throughput is this for that latency, it's simply okay, this is our system and again this is my input and again this is my output. So latency is something like how many number of cycles or how many number of how much time it is taking, the input is taking to reach my output. So that is we are calling as latency. Okay, so consider this particular system. Instead of system we have here only two delay element. Okay, 2D flip flop you have, this is one D, this is one D, so this is your QQ, and if it is going out means, so here it is taking, here we are not at all caring about any of the frequency and all, like here one if we mention this is the time we can just tell that, but here if you see the output and input, between output and input it will take only 2 cycles of this particular clock what we are giving. So this clock can be anything. So here if it is your output will be 2 cycles, after it will be delayed version of input after 2 cycles. So here the latency is 2 cycles. If the clock is like 1 megahertz, so your time will be 1 microsecond. So here the latency will be 2 microseconds. Got it? So here consider this is a clock, here 2 flip flop, so clock is 1 megahertz. So your time period will be 1 millisecond and your latency will be 2 microsecond. This is because it is flowing through the 2D flip flops. So this will cost 1 microsecond and this will cost 1 microsecond. So you will be getting 2 microsecond latency at the output. So this is what about latency, that output the delay between the input to reach the delay for the input to reach the output is called latency. Yeah, this is what about latency. Okay, so now we talked about the latency and we talked about the latency as well as we talked about the throughput, right? So the jitter we will talk about. Actually the latency as well as the throughput is like, in a logical term also we can define that. It's like the latency is just a predetermined delay between the input and output. So there we will be having the logic element like flip flop or any of the delay elements will be having, some compound logic also will be having. So the latency is a fixed or the prefixed element, that is like if you see that it won't change per clock to clock. It's like if I am giving my input like this, right? If my input, if this is my clock, we have discussed, right? This is my input means it will be after, here you had started, right? So after 2 clocks of this you will be getting this. So for you it won't change, right? It won't change after this clock cycle also. Here you are sending 0, that's why it is making it 0. If again you change your things after 2 clock cycle, it will be prefixed for all the clocks, all the clock cycles. For here also it will be same, here also it will be same, here also. This is the predetermined delay. It's a needed, or this is the fixed delay what we are expecting at the output with respect to the input. Okay, so that is what the latency. But this is that unusual delay, or the delay which is introduced by the channel or something. If you see, if my clock is this and my input is this, okay, my input is this, so same as that I am expecting. Consider here only one delay you have, so you will be expecting this particular one at output, right? So after some time you will be expecting, so this particular one high you will be expecting here, right? You will be expecting here, but due to some system, some electrical characteristics or something, your input is just delayed here. Consider your input is here, it is getting 1. This delay is, right? So this delay between your actual active edge and the place where your input or thing is getting shifted, right? So this shift happens because of the channel characteristics. It's not because of the any other delay element what we have added. It's like some electrical specified things, the channel or any other element which is introducing this delay. This is not like it's not like it will be repeatable. It won't repeat until it won't repeat. It may have different version of it may get increased in the next cycle, or it may get reduced, or it may be nullified also in the next cycle, something like that. But it is not an usual delay, it's an unusual delay, as well as it's a delay introduced by any of the channel elements, and it is the unexpected delay. Okay, so that is what I am trying to tell. The latency is the delay which is we are expecting because of the design element what we have given there, and the jitter is the unexpected delay which we are not expecting. It's because of the some channel characteristics it is coming. And another thing what we have discussed, the throughput, right? The throughput is it just like a performance measure, so that we are giving to one system. It's like this is your throughput. Then means the operating frequency, right? The max operating frequency of that, or it's like how it is its performances. So that is one of the performance measure. And the latency also, it's big, like because of the latency we will be it may be given because of some of the timing things also, right? So because we can't through in one stretch all the combology we can't through, because based on the it will be lot of things, right? There will be a max operating frequency of the system. So because of that only we are introducing the latencies there. So just to compensate all the timing related stuffs. So the latency is the desired one that we have designed based on the architectural stuffs, based on the timing and all. And the jitter is the unusual thing and unwanted thing that is introduced because of the channel. That also we have to take into consideration during the timing analysis. Okay, to just nullify all the things, we will be introducing some of the extra buffers and all to nullify the effects of the jitter. And the throughput is just a performance measure of that. These are all the difference between these three. Okay, thank you.